Hello, and I welcome you all to Scientific Study for You. I am Apur Pathak, and after watching this video, you will be able to solve a very common type of question frequently asked in competitive examinations where they ask about the group and period of an element and the block the element belongs to. So let's get started. So first is the S block elements. Okay. So first of all, I would like to start with the electronic configuration of francium, atomic number 87. But if you guys have difficulty in writing the electronic configuration of elements, then I have made a detailed video about the electronic configuration, which if you will watch, you will be master in writing electronic configuration. So I will highly recommend you to check the link given in the description about that electronic configuration video, and after that you come to this video. Okay, so again let's get started. So first two electrons will go in the K shell. After that we will go to the L shell, 2 electrons, and we will check if the n-2 doesn't exist or have fully filled or have 32 electrons. In this case it doesn't exist, so no problem. We will check n-1 shell, and we will check if n-1 shell is fully filled or having 18 electrons. In this case it's fully filled, so no problem. We will go up to 8 here. Again octet rule will come in picture, that's why we will go to the next shell. Again we will check n-2 shell. In this case it's fully filled, so no problem. Then we will check n-1 shell, it's again fully filled, so no problem. We will go up to 8 here, and again octet rule will come in picture, that's why we will move to the next shell. Again we will check n-2 shell, it's fully filled, so no problem. Then we will check n-1 shell, it's having 8 electrons, neither fully filled nor having 18 electrons, that's why we will move up to 18 here. After that we will go up to 8 here. Again octet rule will come in picture, that's why we will move to the next shell. Okay, again we will check n-2 shell. In this case it's fully filled, so no problem. Then we will check n-1 shell. In this case it's having 8 electrons, neither fully filled nor having 18 electrons, that's why we will move to 18 here. And then we can move to 8 here. Again the octet rule will come in picture, that's why we'll move to the next shell. Then we will check n-2, it's having 18 electrons and it's not fully filled, that's why we'll move up to 32 here. And we will check n-1, it's having 8 electrons, that's why we will move up to 18 electrons here. Then we can move up to 8 here. Again octet rule will come in the picture, that's why we will move to the next shell, putting the 1 electron. So the last electron enters the last shell. Okay, so when the last electron enters the nth shell or the valence shell, and there are electrons ranging between 1 and 2 in the nth shell, which means that in the last shell the electrons is either 1 or 2. In such cases the element is said to be an S block element. Okay, when the last electron enters the last shell, which is the valence shell or nth shell. Okay, and the electron is ranging between 1 or 2. In such cases it is said to be an S block element. Okay, and for S block element the calculation of period will be the maximum number of principal quantum number n. For example, here in case of francium, 1 2 3 4 5 6 and 7 is the largest value of principal quantum number. Okay, that's why the francium belongs to the 7th period. Okay, and for group, the number of valence shell electron will tell the group number for S block elements. Okay, for example, in case of francium, there is only 1 electron in the nth shell or valence shell, that's why francium belongs to group 1. As you can see here, francium belongs to group 1. Okay, now we will move to the P block element. Okay, again the P block element, we will start with the electronic configuration of thallium, atomic number 81. Okay, again 2 electrons will be put in K shell, 2 electrons in the L shell, and then we will check n-2, and then we will check n-1. Both are all right, that's why we will move up to 8 here. Then octet rule will come in picture, that's why we'll move to the next shell. Again we will check n-2. Okay, then we will check n-1, it's okay, so we'll move up to 8 here. Again octet rule will come in picture, that's why we'll move to the next shell. Again we will check n-2, it's okay. We'll check n-1, it's having 8 electrons only, that's why we will move up to 18 electrons here. Then we can go up to 8 here. Again we will move to the next shell. Again we will check n-2, it's okay. Then we will check n-1, it's having 8 electrons only, that's why we will move up to 18 here. And again we will move up to 8 here. Again octet rule will come in picture, that's why we will move to the next shell. Again we will check n-2, it's having 18 electrons only, that's why we will move up to 32 here. Then we will check n-1, it's having 8 electrons only, that's why we will move up to 18 here. And after that we will count 8 to 10, 18, 60, 78, 78 to 80. Okay, so 1 electron more needed, that's why we will go up to 3 in the last shell. Then we can count, it's 60, 78, 81. Okay, so it's done. So we can notice here the last electron enters the last shell again in this group. Okay, So when the last electron enters the nth shell or valence shell, and there are electrons ranging between 3 and 8, that's why, which means that the last electron enters the nth shell and electron ranges between 3 and 8, that is 3, 4, 5, 6, 7 or 8. Then in this case, the element is said to be a p block element. Okay. When the electron enters the last shell or valence shell and the electron ranges between 3, 4, 5, 6, 7 and 8, then it is said to be a p block element. Okay. So counting the number of period number for p block element will be same as the s block element. Maximum number of principal quantum number n will say the number of period. That's, for example, in case of thallium, there are 1, 2, 3, 4, 5, 6 is the maximum number of principal quantum number. That's why thallium belongs to 6th period. As you can see here, thallium belongs to 6th period. Okay. And for calculating the group, it says that the group number will be 10 plus number of valence shell electrons. For example, in this case, there are in case of thallium, there are 3 electrons in the valence shell. That's why the group number will be 10 plus 3, which will be 13. So for example, here I have seen thallium belongs to group 13. Okay, easy, no problem. Now let's move to the d block elements. Okay, again we will see an electron configuration of Rutherfordium, atomic number 104. Okay, again 2 electrons here, then 2 electrons here. We will check n-2, it's okay. We will check n-1, it's okay. Then we'll move up to 8 here. Then octet rule will come in picture. Then we'll move here 2 electrons. Then we will check n-2, it's okay. We will check n-1, it's okay. So we'll move up to 8 here. Again we will check, again we will move to the next shell. Then we will check n-2, it's okay. We will check n-1, it's having 8 electrons only. That's why we will move up to 18 electrons here. Okay, then we can move up to 8 here. Again we will move to the next shell. Then we will check n-2, it's okay. Then we will check n-1, it's having 8 electrons only. That's why we will move up to 18 here. And then we can go up to 8 here. Again we will move to the next shell. Again we will check if n-2 is okay. No, it's not okay. It's having 18 electrons only. That's why we will go up to 32 electrons here. Okay, then we will check n-1, it's having 8 electrons only. That's why we will move up to 18 electrons here. Then we can go up to 8 here. Again we will move to the next shell. Again we will check if n-2 is okay. No, it's not okay. That's why we will go up to 32 here. Then we will check n-1. We will see, we will put 10 more electrons and it will be done, the electronic configuration. So in this case, the last electron enters the n-1 shell. If this is the nth shell, this is the n-1th shell. So the last electron enters the n-1th shell. So in such cases where the last electron enters the n-1th shell, okay, and the electron ranges between 9 to 18. For example, in this Rutherfordium, the last electron entered the n-1th shell and it was 10 in number. So in such cases where the last electron enters the n-1th shell and it ranges between 9 and 18, then the element is said to be a d block element. Okay, means the n-1th shell should be getting filled and the electrons should be ranging between 9 to 18. Then it is called a d block element. The period number will be same, again maximum number of principal quantum number. So in that case the Rutherfordium, the maximum number of principal quantum number will be 1, 2, 3, 4, 5, 6 and 7. That's why Rutherfordium will belong to the 7th period. Okay, as you can see here, 7th period. Okay, and the group number for d block elements will be 2 plus n-1th shell electron minus 8 electrons. Okay, here 2 is a different term. Okay, and this is in bracket, as you can see. So n-1th shell electrons minus 8. For example, for Rutherfordium, 2 plus 10 minus 8 equal to 2 plus 2 equal to 4th group. Okay, very easy. It's nothing complex. It just looks big, but it's very easy. All right. So let's move to the F block elements. Again, we will see the electronic configuration of this 100. Okay, fermium Fm. All right, so 2 electrons here, K shell. Then we will fill 2 electrons in L shell. Then we will check n-2 is okay, n-1 is okay, so we will go up to 8 here. Then we will go to the next shell because of octet rule. Again we will check n-2, it's okay. Then we will check n-1, it's okay, so we will go up to 8 here. And again we will move to the next shell. Again we will check n-2, it's okay. We will check n-1, it's having 8 electrons only. That's why we move up to 18 electrons. Okay, then we can go up to 8 here. Again, next shell, we will check if n minus 2 is okay. Yes, it's okay. Then we will check for n minus 1. It's having 8 electrons, that's why we'll move up to 18 here. Then we can go up to 8 here. Again, we will move to the next shell. We will check n minus 2. In this case, it's having 18 only, so we will go up to 32 here. Then we will check n minus 1. In this case, it's having 8 only, that's why we will go up to 18 here. And then we can go up to 8 here. Then we will move to the next shell again. Then we will check n minus 2, it's having 18 only. And we can see when we move to 30 here, the electronic configuration will be done. Okay, so we can see here that the last electron enters the n minus 2 shell. It's n shell, then n minus 1 shell, the n minus 2 shell. So last electron enters the n minus 2 shell. And in such cases, when the last electron enters the n minus 2th shell, okay, and the electrons ranging between 19 to 32, okay, electron ranging between 19 to 32, in this case it's 30. Okay, so if the electron enters the n minus 2th shell, the last electron, and the electron is ranging between 19 to 32, then the element is said to be an F block element. Okay, an F block element. And for F block element, again the period number will be same, the maximum number of principal quantum number. For example, in this case fermium, it's 1 2 3 4 5 6 7. Again it belongs to the 7th period, as you can, okay, as you can see here, fermium belongs to the 7th period. Okay, and for group, all F block elements belong to group 3. Okay, and the F block elements are also known as lanthanides and actinides. Okay, so they belong to the group 3 only. All right, now we will solve few questions which has been asked in NEET exam. So let's get started with the questions. All right, so the first question is, the elements Z equal to 117 and 120, elements Z equal to 117 and 120 have not yet been discovered. In which family or group would you place these elements? This is NCERT question. Okay, this is an NCERT question. So first of all, we will write electron configuration of 117, 2 electrons in the K shell. Okay, 2 electrons here. We will check n minus 2, it's okay. We will check n minus 1. Then we will go to 8 here. Then the octet will come in picture, so we'll go to 2 here. We will check n minus 2, it's okay. We will check n minus 1, it's okay. That's why we'll go up to 8 here again. Okay, then octet will come in picture, so we'll go to 2 here. We will check n minus 2, it's okay. We will check n minus 1, it will go up to 18 here. Okay, then we can go up to 8 here. Then again octet will come in picture, so we'll go to 2 here. Again we will check n minus 2, it's okay. We'll check n minus 1, it's not okay. That's why we'll go to 18 here. Again we can go up to 8 here. And again we'll move to the next shell. Again we will check n minus 2. In this case it will go to 32 here, and n minus 1, it will go to 18 here. Okay, again we will go move to 8 here. Again octet will come in picture, so we'll move to 2 here. Okay, again we will check n minus 2, it will go to 32 here, and n minus 1, it will go to 18 here. Okay, and 18 here, and we will then count. Okay, how many electrons already done? So it's 60, 90, 92, 800, 110 and 102. So 5 more, so it will go to 7 here. Okay, it will go to 7 here. So let's count again. It's 60, 90, 92, 800, 110 and 7, 170. All right, so the last electron enters the last shell and it ranges between 3 to 8. That's why it's a which block element? Tell me. It's a P block element. Okay, P block element. Okay, and the group number will be for P block elements, the group number was 10 plus number of valence electrons. In this case it's 7. That's why group number 17. Okay, in the next question, question number 120, atomic number 120, again we will start writing the electronic configuration. Okay, again we will start writing the electronic configuration here. 2 electrons in the 2 electrons in the K shell, 2 electrons here. Then we will check n minus 2, it's okay. We'll check n minus 1, it's okay. So we'll go up to 8 here. Again we will move to the next shell. Again we will check Okay, n minus 2 is fine, n minus fine, we will go to 8 here, then we'll go to 2 here, again we will check n minus 2 is fine, n minus 1 is not fine, so we'll go to 18, and we'll go to 8 here, again we will go to the next shell, again we will check n minus 2, it's okay, n minus 1 it's not okay, so we'll go to 18 here, again we will move to 8 here, then we will go to the next shell, again we will check n minus 2, it should be 32 here, then n minus 1 should be 18 here, then we'll move to 8 here, again we will go to the next shell, we will check n minus 2, it should be 32 here, n minus 1 should be 18 here, okay, and we will count first, okay, all right, 60, 92, 100, 110, 112, so 8 more electrons, so it will be up to 8 here and 2 electrons here, okay, so it will be 92, 800, 110, 118 and 220. So the last electron enters the nth shell, okay, again, and electron is ranging between 1 or 2, that's why it's a s block element, okay, s block element, okay, and the group number will be number of valence electron, group number will be number of valence electron equal to group 2, okay, group 2. All right, very easy question, but it is very important from the perspective of exam, okay, it's very easy. And you can tell the period number in both the cases. In this case, period number will be in the previous case, period number will be, you will have to count 1 2 3 4 5 6 7, so period number will be 7 in this case, and in case of 120 the period number will be, again you can count 1 2 3 4 5 6 7 and 8, so period number will be 8, which doesn't exist actually. Period number will be, okay, period number will be 8. So the next question is from NEET, and the question says, if the atomic number of an element is 33, okay, if the atomic number of an element is 33, it will be placed in periodic table in which group? Okay, again 33, we will write the electronic configuration first, 2 electrons here, then 2 electrons here, will n minus 2 is okay, n minus 1 is okay, so we'll move up to 8 here, then we will move to the next shell, okay, again we will check n minus 2 is okay, n minus 1 is okay, so we'll move up to 8 here, then we'll move to the next shell, again we will check if n minus 2 is okay, yes it's okay, then we will check if n minus okay, no it's not okay, we will go to 18 here, okay, we will count 18, 10, 28 to 30, so 3 more electrons, so it will go up to 5 here, okay, so the last electron enters the last shell and ranges between 3 to 8, that's why it's a p block element, okay, it's a p block element, and for group number it will be group number 10 plus valence electrons equal to 10 plus 5 equal to 15th group, okay, 15th group. It was a neat questions, you can imagine it's so easy. 15th group, option C, very easy, it was a neat question, okay. The next question, so the next question again, the electronic configuration of an element is 1s2, 2s2, 2p6, 3s2 and 3p3, okay, so we should count the total number of electrons first, it's 2 2 4, 6 4 10, 12, 3 15, so here z is equal to 15, okay, z is equal to 15, and the question asks that what is the atomic number of an element just below the above element in the periodic table, okay. So first of all we will write the electronic configuration, this is again a neat question, okay, first of all we will write the electronic configuration for this element, okay, we will write the electronic configuration for 15, so 2 here, n minus 2 is okay, n minus 1 is okay, okay, so we will go up to 8 here and then 2 here, then we will check, yeah, n minus 2 is okay, n minus 1 is okay, so we'll go up to 5 here, right, 5 here. So last electron enters the n shell and its ranges between 3 and 8, that's why it's a p block element, and the period number is how much? 1 2 and 3, period number is 3, all right. Now to check an element just below this element, we need to see that we have to go to the next period, and as we know the period number is determined by the maximum number of principal quantum number, that's why for the next period we need to increase the principal quantum number from 3 to 4, okay, while keeping the group same, which means the last shell electronic configuration will be same, 5 electrons in the last shell, okay. So let's see 2 electrons here, 2 electrons here. Okay, then we will check n-2 is okay, n-1 is fine, so we will go to 8 here, again 2 here. We will check n-2 is fine, n-1 is fine. We will go to 8 here, again we will check. Okay, we will check that n-2 is fine, n-1 is not fine. We will go up to 18 here. We will count 18, 10, 28, 30. Okay, and it's the 1, 2, 3 and 4th period. We need to have 4th period same electronic configuration as the previous one, so we need 5 electrons here. Let's count 18, 10, 28, 5, 33. Okay, so electronic configuration final is 2, 8, 18 and 5, and total number of electrons will be 2, 8, 10, 28, 5, 33. Okay, so the element is having 33 atomic number, which is just below the atomic number 15. All right, we just needed to increase the period by 1, which means increasing the principal quantum number by 1 while keeping the group electronic configuration the same. That's why we found that 33 is the element. So the option was A. Okay, the option was A, 33. All right, it was a neat question again, very easy. All right, let's move to the next question and the last question. The element Z equal to 114 has been discovered recently. Okay, it will belong to which of the following family or group? A, carbon family, B, oxygen family, C, nitrogen family, and D, halogen family. It's again a neat question. I haven't mentioned it. It's again a neat question, 2017. Okay, neat 2017. So again we will write the electronic configuration for 114. Okay, 2 electrons here, then 2 here. We will check n-2 is fine, n-1 is fine. So 8 here, then 2 here. We will check n-2 fine, n-1 fine, that's why 8 here, then 2 here. n-2 is fine, n-1 is not fine. We will go to 18 here, then we can go to 8, then next 2. Again we will check n-2 is fine, n-1 is not fine, up to 18. Then we can go up to 8 here. Again we will go to the next shell. We will check n-2, it should be 32. Then we will check n-1, it should be 18. Then we can go up to 8 here. Then we will again go to 2 here. Again we will check n-2, it should be 32. Then we will check n-1, it should be 18. Then let's count 60, 92, 100, 110, 102. So 2 more electrons. It will go up to 4 here, right? It will go up to 4 here. So the last electron enters the valence shell again. Okay, last electron enters the valence shell again. Okay, and it ranges between 3 to 8. Then again it's a p block element, right? It's a p block element. And for p block element, group will be calculated as group is equal to 10 plus valence electron, so it's 14. So group 14, and group 14 is carbon family, right? Group 14 is carbon family. So it's the carbon family element. Okay, so it was a very easy question again. So I would like to conclude this video. Okay, so in this video we have learned that when the last electron enters the valence shell and the electron ranges between 1 or 2, then it's an S block element, and the period number is calculated by the maximum number of principal quantum number, and the group number is calculated by the valence shell electrons. Okay, if the electron enters the last shell, again NS shell, and the electron ranges between 3 to 8, then it's a p block element. Okay, it's a p block element, and period number will be same, again the maximum number of principal quantum number, and the group number will be 10 plus the valence shell electrons. Okay, and if the last electron enters the n-1 shell, okay, n-1 shell, and electron ranging between 9 to 18, then it belongs to a d block. Okay, and the period number will be the maximum value of principal quantum number n, and the group number will be 2 plus n-1 shell electrons minus 8. Okay, and if the electron enters the n-2th shell, the last electron, and the electron ranges from 19 to 32, then it's a F block element, and F block elements belongs to group 3. The period number will be same, maximum number of principal quantum number. Okay, and again I am saying that if you have difficulty in electron configuration, I have made a detailed video about electron configuration. Go and check the link in the description and learn the electronic configuration and master it. So that's it for the video. Thanks for watching.